Hello everyone, this is Dr. Abhijit Das, MD in Community Medicine. Happy Teachers Day to everyone. Let us discuss about biostatistics. So we know that biostatistics is an important part of community medicine. This chapter is going to be a basic beginner for all who are studying in MBBS. And for learning community medicine, this will be very important to understand the basics of biostatistics. This is also going to help the PG students who are revising their community medicine and trying to develop a concept in biostatistics. You can expect MCQs in your next FMGE and NICET and NEET examinations also from this chapter. So I request everyone to focus and understand the basic concepts so that we can proceed with much more deeper and more applied aspects of biostatistics in our future lectures. So what is statistics? You see here, the term is statistic or datum, right? Statistic or data. So statistics is actually the plural form. Statistics or data. It is, what is that? A measurable or counted fact or piece of information stated as a figure which has such as height of a person, birth weight of a baby, etc. So a full information or a partial information which is presented in the form of figure is statistic or data. What is statistics? So when you talk about statistics, though it is a plural form of statistic, we consider it as a subject. So statistics, a science of figures. As there was a definition coined by Horace Socrates. Definition is the aggregate of facts affected by multiplicity of causes. So there are some factors. If you try to understand the concept, this is a very precise definition which explains entire thing of statistics. The aggregate of facts affected by multiplicity of causes. So there will be various causes which are affecting the facts, which numerically expressed. So expressed in numbers, enumerated or estimated according to the reasonable standard or accuracy. So there will be some standards against which they are measured. For example, if we are measuring the height of a person, there will be some standard units of measure. And if we are going to categorize the person's height, the person categorize the population as per height, we are going to follow some standard definition, like how much is the appropriate ideal height, how much is more than average, how much is below normal for as per normal and distribution in the community. So that is why it is said that collected in a systematic manner and with a reasonable standard and accuracy, collected in a systematic manner. So there will be some process which will be followed. We shall come into this while collecting the data. Various processes are being followed, like for a specific study, when data is collected, some specific definitions are followed, and specific methods such as sampling methods, which are standard methods, these are followed for collecting the data for predetermined purpose. So when we collect data, there is definitely purpose. So then we may do a survey or research study, maintenance of records. These are ideally the purpose of, usually these are the purpose of collecting the data and placed in relation to each other. See how important everything is placed in relation to each other. See, in upcoming discussion we shall discuss about, there is variables or attributes, and we have frequency or observation. So it is not merely collection of data. Data will be presented as connecting to variables. Suppose one variable is weight of a person. So against the weight of a person, we shall be tabulating the data, like person 1 72 kilo, person 2 53 kilo, person 3 68 kilo accordingly. So it is related to each other, and when each data is related to each other, we may design it in ascending order, descending order, or in strata or categories. We can divide, like say above 50 in one category, 75 51 to 75 in another category, 76 to 100 in another category. So this is how it is presented in relation to each other. I hope it is clear to everyone. Next is where comes our area which we deal with is biostatistics. So what is biostatistics? When the tools of statistics, so biostatistics, when the tools of statistics are applied to the data that is derived from biological sciences such as medicine, okay, then it is called biostatistics. When tools of statistics are applied to the data that is derived from biological sciences such as medicine. What is medical statistics or biostatistics can be also called as quantitative medicine. So this term is not usually used. This is also another terminology depicting biostatistics. Biostatistics helps us to understand the variation in status of health with variation in data. It is thus also called as the science of variation. Right? So various definitions we have gone through. Now let us understand what are the various statistical applications, methods and their applications. So for such a study of figures, one has to apply certain mathematical techniques called statistical methods, such as calculation of standard deviation, standard error, preparation of life table, etc. So these are some of the methods which are applied in biostatistics. Medical statistics go under different names when applied in different when applied in different fields, such as health statistics in public health or community health. When biostatistics is applied, it may be called health statistics. Medical statistics in medicine related to the study of defect, injury, disease, efficacy, drug, serum and line of treatment, etc. These are medical statistics. Vital statistics in demography pertaining to vital events such as birth, marriages and deaths. The vital statistics here means related to the community. Common statistical terms. So here we shall learn about certain terms which will be invariably used in statistics. So understanding this term, the meaning of this terminology is very important. Otherwise, in future lectures, we are not going to understand that what is meant by this terminology. So first we go variable, a characteristic that takes on different values in different persons, places or things. It denotes X and a notation for orderly series x1 to x3 it is mentioned as series. So any variable can be denoted as X. Say in a community you are going to observe, say, the height of boys in a class. So you start collecting the data and you mention the height, you collected the height of 30 boys from a classroom, where you collect the information. These can be, every observation can be depicted by X. Say x1, say 140 centimeter, say x2 142 centimeter accordingly. That is how the data will be collected from, and it is mentioned as a series x1 to say xn. So n means the highest number of observations. So here it will be x1, x2, x3 continued up to your x30. So this is how we collect our information and tabulate them. Okay, and sigma sign or summation sign stands for the result of observation, summation of the results of observation. So you will how we shall mention when you mention the summation, say sigma x1, x2, x3 up to xn, or say for in this case say x30. So that is how we are going to mention the total of the total of the observations, total of the height of the class, the boys in the class. So next is constant. So constant is quantities that do not vary. Okay, we all know what is constant, I think. So quantities that do not vary. So certain ratios are used for calculations in case of measurements in the population based observations. We shall come to that. So there are certain constant ones which are used. Say for 95%, the standard deviation value is 1.96, and where within which 95% of the observations involved. So you will understand in the upcoming classes. So the constant means quantities that do not vary. We have our goal is here to understand the terminology. Okay. So constant is something for which values will never change. Observation and event and its measurement. So event, what event means here? Event means an event of observation, an event of measuring a data. That is what is mentioned is event. Event does not necessarily mean any occasion. Event means, say you have encountered a patient in OPD today and you have measured the blood pressure which is 110/80. So in this occasion you have got a measurement. That means you have observed the blood pressure of the patient. That is an observation. What is observational unit? The source that gives observation, that is object, person, etc. Observational unit. Say here the patient is the observational unit. Observing whom you have got the observation is the observational unit. So when you do study in a community, or say in a indoor of a hospital, if we measure certain observations from the community, the residents are the observational unit. In indoor, the patients from which we are collecting the data are the observational units. What is data? A set of values recorded in one or more observational units. So from one of these observational units we collect the information, that is nothing but or data. Moving on to next terminology is population. It is the entire group of people of study. So this one is this terminology is basic of biostatistics and epidemiological study. So what is population? It is an entire group of people or study elements. So the group of people we are going to study, not necessarily the population of a state or a district or a country, the entire group of population we are studying. Say in a cluster study, we shall come to that. In a cluster we are taking 100 people. We shall take various measurements from them, various observations from them, from these observational units. So total 100 observational units will be measured. Okay, so this is our population, the study population, right? Out of that, again another terminology come, what is sample? We shall come to that. So we are going to find out what is the status of these 100 people, or say in a subcenter area, say 5,000 people are there. We are going to find out, say, the prevalence of hypertension among these populations. So this 5,000 population is our population for the study. Similarly, if it is not biostatistics, say we are going to find out about or say in biostatistics also, let's say about equipment. So say in Tripura there are 1000 X-ray machines in public health system, right? Let us assume that out of that we are trying to find out the prevalence of X-ray machines having CR system. So say these 1000 X-ray machines, these is our study population. So not only people, it is also elements. Now population can be finite population which has endless infinite, which has endless succession of values. So for an infinite population is not defined, so we keep on getting observations and counting them. Infinite population, it has fixed number of values, so population is predefined. Okay, so in infinite cases we get qualitative data, gives qualitative data here. So infinite, we usually understand when it is infinite, the term infinite is used, we usually get confusion. We understand that means a lot of population, right? And finite must be a limited population, but it is not so. The understanding is has to be a little different. I'll explain it. Say infinite population means, say in a qualitative study we are going to do interview by convenience. So what we are going to do, say we have got 3 people, we got interview them, then we keep on going, get another 1 person and then another 1 person. So number may be less, but the thing is that in infinite we do not know how many we are going to interview. We are going to interview as many as we get, and we are going to add on the observations. So this is infinite. Infinite population we predetermine, like I have mentioned earlier. Say in case of a subcenter area population, 5000 population. So we have predetermined that we are going to collect the observations from these 5000 population. Maybe a sample of that, we shall come to sample later on, and use a quantitative data. So usually in quantitative methods we use a finite population, which may be when we look into the observations, a study of a finite population may be higher than when we have studied an infinite population. Now understanding next terminology, sampling unit. Each member of a population, or observational unit, same thing, sampling unit. So when we go for sampling, we first define a population, finite population. Again I am mentioning that 5000 population, or say 30,000 population in the PHC area. Okay, so they are sampling unit. Out of that, what we choose, out of that, based on some criteria, we choose a group of sampling units that form part of a population. So a part we shall choose as sample, study sample. So there will be various checks and measures, various methods by which we choose an ideal sample size, and accordingly we choose a sample. But what we are going to choose, we are going to choose a certain number of sampling units, and which we shall study to find out the status of the entire population. So there is population house, part of population house sample is generally selected so that a representation of the presenting whose variables are under study. Okay. That is parameter. This is another very important terminology. It is a summary value or constant of a variable that describes the sample. So every sample will have a summary value, say mean, standard deviation, standard error, correlation coefficient, and proportion, etc. For example, we are from the for studying the 3000 population, we have at the end of the day we have collected 120 sample based on a legitimate sampling technique, right? Sampling technique and measure, checks and measures of sample size. We have decided that we shall be actually observing a sample of 120 sampling units, say 120 people, and we are going to measure the hemoglobin percentage to find out how many of them are anemic, how many among the 30,000 population having anemia. So it is expected that when a sample is collected by normal method, all the parameters will be as in 30,000 population, the distribution how it is. Suppose low hemoglobin level, people with low hemoglobin level, as much percentage is there in 30,000, same will be there in among the 120 population. So also for normal hemoglobin. That is what is expected when a proper sampling technique is applied to collect a sample. Now when we measure the hemoglobin percentage for this population, there is we shall find a, say, mean hemoglobin percentage, and we shall also find for this population a standard deviation, standard error. We shall understand all these terms in upcoming classes. Correlation coefficient, these are certain measures which are never going to change for this population if measured properly, right? If our observation is valid, then these will never change. That is why these are constant, and these things are called parameters of that population. See, when we take, say, some certain object, say wooden block, right? For an object, wooden block, this will have a weight, a height, length, breadth. These are constant for this block. These will never change. So also for a population, these are the parameters for the wooden block. So also these are never going to change for a population. So these are the parameters for a population, right? Now moving on to, based on statistical test, going to statistical test based on the parameter of the population. The statistical tests are broadly divided into two categories. One is parametric test, next is non-parametric test. So what is parametric test? A summary of constant of a variable. What is a parametric test? A summary value of constant of a variable that describes sample mean, variances. So summary value of a constant of a variable that describes a sample. Okay. So in parametric test there are also mean and variances. So what are the characteristics of a parametric test? Data tend to follow the assumed and established distribution, right? So in parametric test, the data tends to follow the assumed or established distribution, which are normal distribution, binomial distribution, Poisson distribution. So it is not going to impose any values from outside onto the population. It is going to measure the parameters of the population, right? The population has its own statistical characteristic which is not modified. See, this is the key word. It is not modified. The population statistics is expressed by statistical test. So population will from the observations of the population, we shall have mean, we shall have variances, we shall have data, and to follow one assumed or established distribution like normal distribution, binomial distribution, Poisson distribution. Okay. So we shall come to details in next lectures. The population has its own statistical characteristic which is not modified, and from that statistical distribution, mean, variable, standard deviation, these things will be measured. These are called parametric test. And coming to non-parametric test, The constant of the population is used, it will be used, but we are going to impose certain measures onto the population, like data do not follow any specific distribution. No assumptions are made in non-parametric test. Here we shall not make any assumptions based on the population. Arbitrary values are allocated against population. Say we have understood what is parameter of a population. Now what is non-parametric test? Say there are body weight of students in a class, right? This is a continuous data we shall be collecting. Say body weight is starting from, say, as if we arrange them in ascending order, say on a scale we can design them. Say this is a scale, say we are starting with 50 kilo, 52, then say 55, 58 kilo, then say 60 kilo. That is how we are going in ascending order and arrange the data. Now here we can categorize them into various categories. Say up to 55 kilo, category 1, up to 60, 55, 6 to 60, category 2. So that is how we are going to categorize the. So here we are giving some values. Say here, say grade 1, here say grade 2. That is how we are giving some valuation on the population measures. So we are giving arbitrary values on our own based on the study technique or research question. So that is how we are putting arbitrary values on the population observations, right? One example of such test is chi-square test. So we shall be understanding this in upcoming lectures. So what is the limitation of biostatistics? Just for interest, you can go through this. Not suitable for studying qualitative phenomena. So statistics is very much good for quantitative phenomena, quantifying things and expressing in numbers. For qualitative phenomena, it is not very much suitable. Does not study individuals. It does not study individuals, but only it studies the observation. Statistics laws are not exact like laws of physics or natural sciences. So these are the limitations of biostatistics. This has been my discussion on introduction to biostatistics. This understanding will be hopefully very much basic and required for understanding the concepts of biostatistics and various statistical methods and epidemiological methods in upcoming classes. I hope you have understood what I have tried to explain. You can also expect questions, as I have mentioned at the beginning of the video. There will be certain also some MCQs you can expect from this chapter, and it is also going to be very important for the beginners who are learning community medicine, and also for the PG students who are revising their community medicine. This I thank and end my video. If you like this video, you can please subscribe my YouTube channel and share this video to as many students and PG aspirants possible, so that everyone gets benefited from this video. And with this I shall conclude today's class. Thank you.